This meeting is being recorded.
In section 13.3, we're going to begin a discussion of both the structure and properties of ethers. So the first thing that we'll take a look at here is the bond angle that results in an ether. We're told that it's very similar to that found in a water molecule, which has about that 105-degree bond angle. And then we have this interior bond angle here for our methanol is around 109. And then we can see that our dimethyl ether would have a bond angle around 112 degrees. We also see that the oxygen atom in each of these three cases is sp3 hybridized. So there's that similarity as well. And the reason that our bond angle gets larger and larger has to do with the size of our R groups. So the larger the R group, the wider the bond angle that results. Ethers cannot do hydrogen bonding as much as alcohols. We know that alcohols have relatively high boiling points because of this hydrogen bonding, but ethers, they can only accept as H-bond acceptors. They cannot donate a hydrogen bond like an alcohol. So there's a slight difference between alcohols and ethers in the fact that they cannot hydrogen bond effectively as alcohols can. Another property that we can discuss is that of boiling point of ethers. And since we know that they cannot hydrogen bond among themselves, their boiling points will be much lower than that of alcohols of similar size. So we can see in this comparison here that ethanol has our highest boiling point because of that hydrogen bonding capability. Then we see that the polar compound in the middle here, dimethyl ether, has a much lower boiling point of -25 Celsius. And we can see on the right-hand side here that a similar hydrocarbon like propane would have the lowest out of the three because it only has those London dispersion forces. And we can also see this here with a trend with the increase in size of ether. So again, those London dispersion forces are present, and the larger our ether, the larger the molecule, the larger these alkyl groups, the higher its boiling point because of those London dispersion forces. So we can see that a dipropyl ether is almost as high as water. It's about 91 degrees Celsius versus a much smaller ether, dimethyl ether, has a boiling point around -25 Celsius. So ethers are commonly used as solvents for organic reactions for a few reasons. So they have relatively low boiling points, as we just seen. So we can perform a reaction and then easily remove the ether afterwards by evaporation. And also, even though they are polar compounds, they are fairly unreactive. So they can be used as solvents and then removed and not affect our results. So we will continue with the next section, 13.4, in the next video.